Hello, and welcome back to another one of our videos for General Triangles Unit 8 Pre-Calculus. Today we are going to put a focus on taking a break from law of sines and law of cosines just temporarily, and we want to actually find area of oblique triangles today, and that's going to be our goal. So today is a supporting skill to our 3.0 proficiency. And let's get started and take a look at some area problems that we may have seen in geometry. So find the area of the given triangle. Triangles are not drawn to scale. The area of a triangle can be considered as two different formulas. Personally, I prefer the base times height divided by 2, but I know when I was growing up, it was always taught to us as 1/2 base times height. They are exactly the same thing, but in order to do the area of the triangle, you have to be able to identify the base and identify the height. So in triangle number 1 here, we have lots of different numbers, and the challenging part of finding areas, you have to know what is the base and what is the height. Many people will just say that 10 is the base, but it is not in this triangle, and that is because the base is always perpendicular to the height. Always. So here's our perpendicular symbol. That means the two segments that are forming that right angle, 7 and 9, those are your base and height respectively. So that's your base, that is your height. So if the area of the triangle is equal to base times height divided by 2, 7 times 9 divided by 2, we'll have 63 divided by 2, which is 31.5 units squared. Remember, an area unit is always going to be squared. And then we get over to this oblique triangle, and they gave me 3 of these sides, and I want to know what is the base and what is the height to find the area. Well, as long as you know this concept that the base is perpendicular to the height, that's going to be helpful. But I don't see any right angles here. And that's because the height is actually outside of the triangle. This is your height. Okay, and your base would be 12. So this is an oblique triangle that formula that we always grew up from grade school knowing, base times height divided by 2, won't apply here. So today we'll have 2 different ways to find that area of that triangle. First things first, we're going to start with what's called Heron's formula for triangle areas, and this is only used for side-side-side oblique triangles. So the triangle that we just saw was a side-side-side, and we could have used Heron's formula to find that area. And without going into the derivation of this formula, basically we need to find something called the semi-perimeter first. And the semi-perimeter is gotten by basically adding up side A, B, and C, and always dividing it by 2. That semi-perimeter will show up in the formula many times. Okay. So the area in Heron's formula is the square root of the semi-perimeter times the semi-perimeter minus one of the sides times the semi-perimeter minus additional side times the semi-perimeter minus the third side. Okay? And we don't need any angles here to find out the area of an oblique triangle. Okay? So here we go. We have find the area of a triangle having the side lengths of 10, 12, and 14. We don't know what the angles are, so I'm just making a generic triangle, 10, 12, 14. The first thing we want to do is find S. And S is equal to the sides added together but divided by 2. So 10 plus 12 plus 14, all over 2. And if you really liked that alpha y equals, you can actually still do that here. 10 plus 12 plus 14, all divided by 2. So the semi-perimeter is 18. Okay. So the area formula says that we'll have the square root of the semi-perimeter, S, and then we'll find the difference of the semi-perimeter in a side, the semi-perimeter in another side's difference, and the semi-perimeter in the third side's difference. So this is now just basically a lot of plug and chug. Don't forget the square root though. So we're going to have 18, and then 18 minus side 1, let's just call it 10. That was the first one in the list. 18 minus 12, and then 18 minus 14. Okay. And then as long as you're really careful with your differences of your subtraction, you could do this calculation of 18 minus 10 in your head. Otherwise, I would use a calculator to double check my work. So I've got 18 times 8 times 6 times 4. And that's the square root of 346. And that means our area is 58.9 inches squared. So Heron's law really isn't that bad. We just want to be mindful of how to find the semi-perimeter. And the semi-perimeter is going to be the 3 sides summed together and divided by 2. All right. I included this next question because I know, everybody always wants to know, well, why is Heron's formula going to be useful? And that's because actually triangles are one of the most common shapes that we can use to build architecture and things like that. So if you did have a field and you bought some more land kind of thing, you would know the distance of the land markers. So you could take your land, divide it into triangles, and then use Heron's formula twice for the triangles. You would just have to realize that that side is used twice. Honestly, in the essence of time, I want to avoid a 30-minute video, so I'm going to actually skip this example. There's really nothing tricky about it. You just got to do 2 triangles together and then make sure you add the triangles together. I would encourage you to try it on your own and ask me for feedback on it to see how you're doing, okay? What if we don't know all 3 sides of a triangle? Well, there is another area formula that exists, and this is used for a side angle side triangle. And this is the area is equal to 1/2 b times c times sine of a. And there's also 3 other individuals here. Notice though, there's never any overlap between the angles and the sides. So if you have sides A and B, the angle you're going to use is C. If you have sides A and C, well, the third missing letter is B, that's why you have sine of B. But this must be used in a side angle side triangle because the angle has to be between the 2 side lengths. Very critical, and this will also hold true when we talk about law of cosines. Right? And this angle right here, we call that an included angle when it's between 2 sides. Okay? That's the key word that tells us it's between things. All right, let's look at one of these area problems here. So find the area of a triangle whose 2 sides of 24 and 10, and an included angle of 62. So I can't use Heron's law because I don't know all 3 sides. I only know 2 side lengths and an included angle. So the area triangle will equal 1/2 side times side times the sine of the angle. That's kind of the general gist of that formula. Okay? But this angle must always be between the 2 side lengths that you're given, the included angle. So the area of the triangle is 1/2 10 times 24 times sine of 62. And there is nothing stopping you from entering this whole expression into the calculator all at once. You can even use the cool alpha y equals trick. Alpha y equals, put your 1/2 in, times 10, times 24, and times sine of 62. Please make sure that you are in degree mode. And that is our area, 105.9 feet squared. And that is the basic gist of how to find the area of an oblique triangle. You will also find one more example afterwards in your packet. I would encourage you to try this example on your own, show it to me complete, and then you should start working on the practice once you have that confidence and you're ready to go. All right, thanks for watching. Have a great day and enjoy your practice work.